All right, starting chapter 5. This first section, completely review. We've had this section before. We're going to refresh your memory on antiderivative. And then as we work our way through this chapter, we're going to have a bunch of shortcut rules. Well, not shortcut rules, but rules that we're going to add to the blue sheet for doing antiderivative. But today, it's just a refresher on how we were doing antiderivative with intuition. An antiderivative is the function f of x is the antiderivative of g of x if and only if we take the derivative of this, we get g back. So, let's start. Number 1. So I'm giving you the derivative function. F of x equals, we'll go 5x to the 4th. And ask you to go back to the equation that has this as its derivative. So we're going back to f of x. Make sure you use the notation. The one thing we know is that the power had to start 1 higher than this. So we start with that by adding 1. And then you have to check. If we do the derivative of this, do we get this back? Well, the 5 would come down times x to the 4th. That is correct. So we're just going to leave it like that. It's going to be x to the 5th with just a 1 there. And then remember, there could have been a constant here, because when we do derivative of a constant, it goes to 0. So that's just the constant of integration that you have to add every time we do antiderivative. So, and that is called the general equation. Because we don't know what c is, and they can ask you for the particular equation, but that means they have to give you a second piece of information so that you can figure out this c. Oh, example 1. So we'll do that in our next one. Number 2. Find the particular equation. That means you're going to find the c value for f prime of x equaling x to the 7th. And we know that the point 110 is on f of x. Okay, so we start by finding our general equation with the plus c. So if we're going backwards. So we'll start with f of x equals, we know we have to start here by adding 1 there. That had to be x to the 8th. And we know we have a plus c, but we'll check if we need a multiplier here. If I leave it just like this, our derivative would be 8x to the 7th. Well, I don't want an 8 multiplier in front, I want a 1. So we need a number here that's going to cancel out the 8. Well, what can you multiply 8 by to get back to 1? Well, it's just simple algebra. Divide by 8, you get 1/8. So you need a 1/8 coefficient. And now if you check the derivative, 8 times 1/8 does go down to 1, x to the 7th, and then our plus c. So there's the general equation. If that's what they wanted, we would stop. But because they want particular, you got to figure out the c. So we know that the x is 1 when the y is 10. So we can substitute in 1 for the x, 10 for the y, and figure out the c. So 10 equals 1/8 times 1 to the 8th plus c. Well, 1 to the 8th is 1. times 1/8. So we're going to be subtracting 1/8. So that means C equals, we'll just go 9 7/8. So our particular equation would be f of x equals 1/8 x to the 8th plus 9 7/8. Oops, sorry. So just filling in for the C value what we found. Checking derivative again. You can always check yourself. 1 x to the 7th, 0. Done. Let's go to the trig ones. Number 3. If our derivative is cosecant squared x, what was the original equation? So you're asking yourself, what gives me cosecant squared when I take a derivative? If you're not sure, use your blue sheet. Looking at our derivative rules, there's a cosine, there's a sine, there's a secant squared. Right there, there's a negative cosecant squared here, and that came from cotangent. So, we know the original function had to have a cotangent in it. And if you check the derivative of cotangent is a negative cosecant squared. Well, I don't want a negative, so I need a multiplier that's going to cancel it. And that would be a -1. So we want the opposite of cotangent, would give us a positive cosecant squared, and then our plus C. So, next, number 4. Can I fit this? I think so. Number 4, we've got the derivative equals cosine 5x. So you're asking yourself, what's going to give cosine when you take the derivative? If you need to look at that blue sheet, look, but you should know by now that when you do the derivative of sine, you get cosine. So you know it has to have a sign. I'm going to leave room for a coefficient here because I don't know if I need one or not. You never change the angle. And we're going to have a plus C. But we're going to stop and check the derivative of this and see if we get this exactly. So if I'm to do the derivative of sine of 5x, we start here. That will be cosine. Keep the angle the same. But then times the derivative of the angle. So that 5 would float to the front. So if I leave it as it is, my derivative is 5 cosine 5x. Well, I don't want this 5 that's here. I want a 1, so I need a multiplier that's going to cancel it. And obviously that'll be 1/5. So if you check the derivative, I'll show you how it works just in case you're not seeing it. We're doing derivatives, so you keep the multiplier of 1/5. Derivative of sine is cosine of 5x times by the derivative of the angle, and you can see the 5 and the 1/5 find each other, brings you back to the 1. So always check your derivative to see if you get the original back. And I have one last problem today. Oh, short and sweet. So number 5. We've got the derivative equals the quantity 4x minus 1 to the 5th. So, we're going backwards. We'll leave a spot here. We know this is going to be a 6. And the only thing you can do is actually do the derivative of this and see how close we are to that. So let's see where we're at. If I do derivative, it's going to be 6 times 4x minus 1 to the 5th. But don't forget the inside derivatives of 4. So my derivative would be 24. 4x minus 1 to the 5th. Okay? So if I leave it like it is, I'd have a 24. I want to cancel out that 24. I want it to come down to 1. So that means this has to be 1 over 24. And then our plus c. And if you check, that will give me 6 24ths times that to the 5th, and then times by the 4, 24 24ths, we're good to go. Okay, that is it. Nice, short, and sweet. Enjoy today.